Every token, every key, no longer your secret. One npm install. That's all it took. Your cloud keys, your GitHub token, your vault secrets, gone. And then it logged in as you and published itself into your own packages. This is the keyv worm, and it swallowed a large chunk of npm in about 90 minutes. Here's the shape of it. At 9:02 UTC on August the 4th, someone holding the maintainer's GitHub account pushed straight to the main branch of keyv. 2 minutes later they added a second set of files, hooks that fire when you open the project in an editor. At 9:35, keyv version 6.0.0 went out to npm. Between 10:09 and 10:14, the rest of the caching family followed: cacheable, flat cache, file entry cache, cache manager. And at 10:28 one more, ecto, published after the first public warnings had already gone up. So what did they actually change? SNYK pulled the published tarball and compared it file by file against the release candidate. Everything under dist, the real library code, was byte for byte identical. 3 things differed. The version number. 1 line under scripts, preinstall, node setup.mjs. And 2 new files added to the published file list. That's the whole attack. The library still worked perfectly afterwards, which is exactly why nobody noticed. It's also the cleanest thing to detect on. Here's the mechanism, and it's the part people underestimate. Preinstall runs automatically, during install, before anything else. You don't have to import keyv. You don't have to start your app. You don't have to call a single function. Resolving the dependency and unpacking it is enough. And this family is almost never something you chose. It arrives underneath ESLint, underneath your build tooling, 3 or 4 levels down the tree. Most of the people hit by this had never typed the word keyv in their lives. The file that runs first, setup.mjs, is only 30 kilobytes, and it does almost nothing interesting. It's a dropper. It downloads the Bun runtime, version 1.3.13, straight from Bun's own official releases page on GitHub, and uses Bun to run the real payload. That second file is 728 kilobytes of obfuscated JavaScript. Why go through Bun at all? Because Bun is a legitimate signed binary from a legitimate release page, so fetching it doesn't look like malware fetching itself. The hostile code never touches the network under its own name. Then it goes shopping. npm tokens, out of every .npm RC it can find, validated live against the registry before it bothers taking them. GitHub tokens in every format they ship in, and on a GitHub Actions runner it reads the runner's own process memory to dump the entire secret store. Cloud credentials, your AWS profile files, the instance metadata service, and secrets manager enumerated across multiple regions. Kubernetes service account tokens, then every secret in the namespace. Vault tokens from 6 different locations, then every key value store it can mount. And roughly 200 file patterns swept across the disk, picking up SSH keys, Terraform state, environment files and password databases. New in this version, the credential stores for AI coding tools. Wiz put the expansion at about 70% more targets than the code it was forked from. Then it turns your credentials into the next infection, and this is the part that makes it a worm rather than a theft. It takes the npm token it just took from you, asks the registry which packages that token is allowed to publish, and starts working through the list. The loop is mechanical. For each package you own, it downloads the current tarball, unpacks it, bumps the patch version by 1, adds the same preinstall line, drops in the same 2 files, repacks, and publishes. Your package. Your account. Valid credentials. Nothing about that publish looks wrong to npm, because nothing about it is wrong to npm. Aikido counted at least 444 packages across 1,381 versions caught this way, with over 2 billion monthly installs between them. Deliveroo, Pixart, Click, Ornicar. Organizations with no connection to keyv at all. There's a second way in, and this one doesn't involve npm at all. When the payload finds a GitHub token it can write with, it commits 2 files into your repositories, a Claude code settings file and a versus code tasks file. The Claude 1 registers a session start command. The versus code 1 uses run on folder open. Read that again. Opening the folder is the trigger. Somebody who cloned the repo purely to read the source, who never ran install, is inside the blast radius the moment their editor trusts the workspace. And the commits are authored to look like a bot, carrying the message chore, update config. They blend straight in. And here's the uncomfortable part. Those malicious releases shipped with valid provenance, signed by GitHub Actions. That isn't forgery. The attacker put the malicious code into the repository first, and then the project's own legitimate release workflow built it, attested it, and published it. The signature is completely true. It says this artifact was built from this commit by this workflow. It does not say the commit was authorized. Provenance proves where a build came from. It does not prove the source was clean, so any control that reads a green attestation and stops there waved this straight through. So, is it in your tree? Start with the resolved dependency graph, not your package.json, because this arrives transitively and it will not be in your direct dependencies. Run npm ls across the affected names with the all flag. Then search your lock files separately, because a poison version can stay pinned in a lock file long after npm has moved the latest tag back to something clean. Removing a version from the registry does nothing to the copy your lock file is still asking for. Names change, behavior doesn't. So look for the shape of it instead. Walk node_modules and find any package whose preinstall is node setup.mjs. Then sweep your home directory and temp for the payload file names, and for the persistence artifacts, which are called ghtoken_monitor. Hold on to that last one. It changes the order you do things in later. Right. Defense. For changes, and they're all boring, which is exactly the point. Boring controls are the ones still standing at the next campaign. Scripts off by default, a cooldown before you install anything new, least privilege pipelines, and no long-lived publish credentials. We'll take them one at a time, starting with the one that would have stopped this cold. Stop running install scripts by default. In npm 11 that's one line in your .npm rc, ignore scripts equals true, plus the same flag on your continuous integration install. In npm 12 this became the default, dependency install scripts are blocked unless you explicitly approve them, and the approval's live in an allowScripts field in your package.json, pinned to the exact version you reviewed. A handful of packages genuinely need install scripts, native modules like Sharp or Canvas. Approve those, by name, and leave everything else dark. That single setting is the difference between a bad news day and a full credential rotation. Second, don't install versions that are minutes old. Most malicious releases get spotted and pulled within hours. Several of these ones were down inside the hour. So put a delay between publish and install. npm calls it minute release age and counts in days. pnpm calls it minimum release age and counts in minutes, and since pnpm 11 it defaults to a day, on, without you asking. Yarn calls it npm minimal age gate, also minutes. Set it explicitly in whichever you use, and set the matching cooldown in Renovate or Dependabot too, or they'll keep opening pull requests for versions your installer then refuses to fetch. Third, assume your build runner will one day install something hostile, and make that boring. Permissions default to read and nothing else. The ID token write permission that lets you publish goes on the publish job only, never at the top of the file, so a job running untrusted dependency code can never mint a publish token in the first place. Pin every action to a full commit SHA rather than a moving tag. Turn the package manager cache off in release builds. And install with ignore scripts, so a dependency cannot execute during your build at all. Fourth, the publish path itself. Get rid of long-lived npm tokens and move to trusted publishing, where npm and your continuous integration exchange a short-lived OIDC token. A token that can't be stolen out of a config file because it never sits in one. Then open your package settings and turn on require two-factor and disallow tokens, so a stolen credential isn't a publish route at all. Go one further with staged publishing. The pipeline can stage a release, but a human has to approve it with two-factor before the public ever sees it. And protect the branch. This whole thing started with a direct push to main. A required review would have put a second pair of eyes between that commit and the release. If you think it did run, the order matters more than the speed. Isolate the machine first and keep the logs. Don't wipe it. Then hunt for persistence before you revoke anything, because the payload can arm a dead man switch that watches a stolen GitHub token and fires when that token stops working. Revoke first and you pull the trigger yourself. Find it, disable it, keep a forensic copy. Then rotate credentials, all of them, from a machine you know is clean. GitHub, npm, AWS, Vault, Kubernetes, database passwords, private keys, anything the build job could see. Then read your audit logs for publishers, new repositories and workflow edits you didn't make. And last, purge your internal registry mirror and your local caches, because npm removing a version from the public registry does nothing to the copy sitting in your proxy. And it will happen again. Shai-Hulud first appeared in September 2025 and took around 500 packages. It came back that November and took nearly 800. Then the source went public, forks appeared, and keyv is a descendant of one of those forks. Wiz traced this payload back to the public mini Shai-Hulud code, with the credential targets widened by about 70%. So treat it as weather, not an event. Scripts off by default, a cooldown on new versions, least privilege pipelines, no long-lived published tokens, and a rotation plan you have actually rehearsed. Put those in now, while it is still someone else's incident. If clear, sensible thinking is what you are after, subscribing is the most direct way to get the next one. See you in the next video.